Hi, folks. Thanks for joining us today for our Safety and Health Magazine webcast. We're going to give our audience just a minute to settle in, and we will start the presentation shortly. Thank you. Thanks again, folks, for being with us. We're going to let our audience settle in for just another few seconds or so before we start the presentation. Thanks. Hello, everyone, and welcome to today's Safety and Health Magazine webcast. Why OSHA made the switch from hard hats to safety helmets, sponsored by MIPS. My name is Barry Botino. I'm an associate editor at Safety and Health and a co host of the On the Safe Side podcast. I'll be your moderator for today's event. Before we get started, I want to inform you that the views of today's speaker and organization are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. Near the conclusion of today's event, we'll conduct a Q&A with our speaker. If you have a question, please just click on that Q&A button located at the bottom of your screen, type in your question, and press the send button. You can submit those questions at any time during today's event. After this presentation, you'll be asked to complete a brief evaluation survey, but I'll tell you more about that a little bit later. This webcast will be archived. If you want to view this presentation or any of our past webcasts, please go to safetyandhealthmagazine.com/events. Now let's introduce our speaker. Joining us today is Joe Brandel. Joe has been in the construction and industrial safety business for more than 2 decades. He currently serves as Business Development Director for the North American Industrial Safety Market at MIPS. He specializes in head protection, hand protection, fall protection, and other personal protective equipment, and has provided training throughout the Midwest for companies of all sizes. Again, we thank you all for tuning into this presentation. With that, welcome, Joe, and please take it away.
Thanks, Barry. And as Barry said, my name is Joe Brandel. I'm with an organization called MIPS. I've been with MIPS for about 2 years. Prior to that, I was a manufacturer's representative and had done a lot of training and consulting in the safety industry, especially around the areas of head protection, hand protection, fall protection, and other areas that Barry had mentioned. So I've been doing this for a while. Like I said, I've been with MIPS for just a little over 2 years. We're an organization based out of Sweden. We have over 100 employees, and we're all dedicated to head protection safety. Over half the employees that we have in our organization are engineers, and five of those have PhDs. Our organization was started by a neurosurgeon many years ago, and like I said, we're fully dedicated to head protection and making products safer. I had mentioned that I had done a lot of training over the years, and I'm based here in Kansas City, home of the back-to-back Super Bowl champions, Kansas City Chiefs, and just in case any of you are NFL fans. And like I said, I've done a variety of training for different organizations, and probably one of the most unique, and I know that photograph is a little small, but up here in the top left-hand corner is a couple guys that, again, if you're NFL fans, you might recognize. One of them is our starting quarterback, and the other one is a Hall of Fame quarterback, Peyton Manning and Patrick Mahomes. So I did slips, trips, and fall training for them. It's a long story. If you want to hear more about it, you can talk to me later or reach out. But it was quite interesting that they had to do it for a current and former NFL quarterback. But that's kind of what you do in the safety industry, kind of get exposed to a lot of different stuff. So again, we'll get going. We're here to talk about head protection and OSHA's move from standard hard hats to helmets for their employees. So let's look at the current standards for OSHA, and this is really construction, but they go across all industries for the most part. And I'm not going to read the slide, but there's two things that I want you to understand and pick up if you don't already. Employers are responsible to keep their employees safe. So one of the main things they have to do is do risk assessments for a variety of things. Anytime there's a risk of an employee getting injured or, God forbid, killed, they need to do a risk assessment and determine what things need to be done, what type of personal protective equipment need to be used, and that sort of thing. So that's obviously, again, that applies to head protection. The other thing I wanted to point out, as far as criteria for head protection, and OSHA doesn't do this a lot, but they do in this case, and they do in fall protection a little bit in some other categories. But they uh, reference ANSI, that the products that the employers use must meet the ANSI standards. And I think that's important because ANSI is those of you that aren't familiar with it, it's American National Standards Institute. It's a governing body for a different variety of personal protective equipment, and they do a lot of testing and set the standards for how the products are made, used, and that sort of thing. So, like I said, it's kind of unique to that, but those are things that OSHA does require in their standards. Now, again, that this is the construction standard, but you do see that in some of their other standards as well. So the basis of this presentation, one of the things I wanted to talk about is OSHA's move from uh, standard hard hats to helmets for their employees. They came out with a directive or safety and health information bulletin back in November, I believe it was November, December, and then they updated it due to a variety of reasons. That they decided to update it and change some of the language in it related to that. But I cut and paste a couple things from that bulletin that I wanted to go over, and I think is very important. And again, I mentioned on a previous slide that all employers who have employees that have a risk of head injury or any injury for that matter, but relative to this discussion, relative to head injury, need to do a hazard assessment at their job site, and based on those hazards, determine what type of head protection is necessary. If head protection is necessary at all, sometimes it's not, rarely, but if it is, the type of head protection that's going to be the most appropriate. And so basically, what OSHA did is they did their own job hazard analysis. And through its results of that, they decided that their employees would be best protected by ANSI Type 2 Class G safety helmets. And so they made the decision to make that move from standard hard hats, to safety helmets, ANSI Type 2 safety helmets. So that's basically the decision they made. Another part of that bulletin from back in March, the revised bulletin, was they made considerations, or they mentioned considerations, that the employers or users should do when selecting head protection for. And these weren't the only three areas of emphasis, but they were the ones that really that they honed in as far as specific products and what type of products. And I highlighted that. It said, construction sites, basically they recommended considering. They don't require it. Words are important when it comes to a lot of different factors, but they mentioned that employers should consider using type 2 ANSI type 2 head protection with chin straps. And we'll get into the importance of chin straps because as far as the ANSI standard goes, they're not required to be used on helmets. So another industry or another part of the sector that they looked at was oil and gas. And again, they mentioned that the employers should consider using type 2 head protection with integrated eye and face protection, like face shields and goggles. And so one other one, and I agree with these pretty much all for the most part, is working at heights. And they didn't really go as far as talking about type 2 head protection as far as working at heights, but they did mention consider head protection with chin straps, to keep the helmet or the hard hat for that matter on the worker's head, because it doesn't matter if it's an ANSI type 2 or type 1 or an EN 12492 type helmet. If it doesn't stay on the worker's head when their head is exposed to a shock or kind of an impact, it's not going to do any good. So right now we'll do a poll. We'll talk about the poll, and I think all of you should see this on your screen. In the first poll question, actually we'll do a couple of them. But the first poll question is, how many of you currently use helmets for your workforce? And so, if you want to answer this question, we'll leave it up for about 30 or 45 seconds, and then we'll talk about the results. So here are the results. So sometimes uses helmets and rarely uses helmets. Looks like the rarely uses helmets, and that's pretty much looks like we got 229 people that responded. And so, that's pretty typical of what I see or have seen over the years. It started probably about 8 or 9 years ago. The helmets coming into the U.S., especially here in construction. So that's what I'm seeing. About 30% of the workforce right now, at least in construction, I would say, is using helmets. And then, sometimes, a lot of that probably has an impact on what the general contractor or what the owner of the facility requires and that sort of thing. So, we still got a pretty fair percentage of people that rarely use helmets. So I'm not saying everybody needs a helmet. I want to make that clear. Type 1, ANSI Type 1 hard hats are widely used and offer a great deal of protection, adequate protection in a lot of different scenarios. But I think in some scenarios, the movement to ANSI Type 2 helmets, especially with a rotational mitigation system in it, is really what's needed. So we're going to do another poll real quick. And this one has to do with if you're using a rotational motion, um, a mitigation system for rotational motion. And for those of you that don't understand what rotational motion is and what the risk is, we're going to get into that later in the presentation. The last several slides will address that. But in the meantime, if you want to answer this question real quick, I'd be curious to know how many of you actually do use helmet now. And again, you can. What I didn't mention before as far as MIPS, is concerned, is we didn't start in construction industrial safety. We started in the sporting goods industry and in equestrian, but we moved into ski helmets, bike helmets, motocross, motorcycle helmets, and that sort of thing. So, we've gotten into other industries as well. We've been in this business for a long time, but relatively new here in construction and industrial, about 3 years now. So again, that's generally a typical response. About 80% of you or 79% do not use it currently. And hopefully after this presentation, whether you use my system or one of my competitors, I hope you consider it because there is a risk due to rotational motion. And again, we'll go over that. So thank you to everyone who responded to the poll. I appreciate that. And again, we'll go on with our presentation. So I want to talk about some of the evolution of other types of PPE, especially in the construction and how it relates to OSHA, because that was pretty much the title of the presentation is OSHA moving from hard hats to helmets. So one of the things I mentioned again, at the beginning is I've been in the construction industrial business for over 25 years. And so, there have been different phases of movement and types of PPE. We're finally getting the head protection, which I would have thought would have happened a lot sooner, but it just hasn't. But we've had movement in other types of personal protective equipment. So those of you that aren't familiar with fall protection, the product on the left is a body belt, and for almost 3 decades since OSHA was created in 1970, body belts were allowed to be used for fall arrest application. Even though, during the 1970s and 1980s, there were different studies done, and even into the 90s, a variety of studies done to prove and to show how dangerous they were to be used for fall arrest application. But then finally, OSHA, made a move in 1996. They made it official in January 1st of 1998 that you could not use body belts for fall arrest application anywhere you're going to put a shock load on the body because of these tests, and they were very different tests. Some of the private sector, some in the ocean, some of the government related tests that they'd done had proved that they were dangerous. And so what did what did OSHA require? And what did the industry move to is a 5-point full body harness, the one on the right. That's what is standardly used for fall arrest applications here in the US. Now, I want to point out That doesn't mean that body belts were banned completely. There are applications where they will work perfectly fine. Those you in fall protection understand and know that, and in a restraint situation where, the worker is not going to be exposed to any kind of a fall, you know, and again, it's all about exposure to that fall is why the body belt was deemed to be dangerous and no longer allowed to be used in those applications. But again, body belts can be used in certain applications, but not fall. OSHA required that move back in, like I said, officially in 1998, but those studies were done for decades before. Another product that has seen a lot of movement in the last, again, probably 20, ever since I've been in the business, 20, 25 years. Again, this is all fall protection related because I'll go through some of the stats and slides, and we'll talk about how falls are still the number one cause of fatalities in construction. And due to that, a lot of different safety leaders, construction company owners, and folks have done their own research, and again, others did too in the private sector. And when they determined that using a standard 6-foot shock absorbing lanyard wasn't going to help, in fact, it was somewhat dangerous to use in certain applications where there wasn't enough fall clearance. And people measured the fall clearance and how much they needed with a lanyard. And there's some arguments as to how much that truly is, but it's well over usually 15 feet or more, where you're going to need that much room or that much clearance to safely use a shock absorbing 6-foot lanyard. And it all depends on where it's connected as far as the anchor point, where it's above your head or below your feet and that sort of thing. But clearance is definitely needed to use that product. I think anybody related in fall protection or safety would agree with that. And so what the construction industry did is we moved towards self-retracting lifelines. And, they came about, in fact, I've got a note at the top, the very first one, to my knowledge, it was in 1940 in a little town in Sweden, and a company that started the solid block. That's where it all came from, was being used in a mine in Sweden. I think the town's name was Solid, and that's where the SRLs pretty much were started. And so that's why I do it. As far as ANSI regulations, I mentioned them earlier. I understand there's new classifications for SRLs, and that was due to movement through the ANSI organization. I think for the most part, it's better. I think if we make the standards less confusing for the user and for myself and trainers and safety folks, it's better for the industry. The last example I'll use for as far as evolution of personal protective equipment or safety equipment in construction is the movement in hand protection that we saw over the last few decades. Brown jersey gloves or standard leather gloves, they were used and still can be used in applications. Don't get me wrong. Just like a 6-foot shock absorbing lanyard can still be used in certain applications, but where there's not enough clearance is relative to the lanyard. That's what's most important here. Well, as far as gloves, whether it's a brown jersey glove or whether it's a leather glove, they don't provide enough protection in certain applications. And therefore, certain folks in the construction industry and industrial sector as well, and a variety of industries, have moved to better products and safer products. And one of those is coated seamless cut resistant gloves. The one on the right is probably one of the most popular in the industry as far as a cut resistant glove. It's not the cheapest, but probably what makes it, and I didn't mention this before, but probably the one thing that drives compliance to me more than anything is comfort. And this product right here is a great example of that. I think I probably of any that I've seen as far as a safety product, and helmets can be that way as well. But when it comes to comfort and fit, that drives compliance, especially with the user, the folks using it more than anything. So the next several slides are going to go over some stats. I want to reinforce how impactful slips, trips, and falls are in the construction industry. And I apologize, I'm sure a lot of you have seen this, some of these slides or most of them, but some people haven't. And I think we need to reiterate how dangerous it still is in the construction industry. So these stats came from the Bureau of Labor Statistics from 3 years, 2019 to 2021. And if you see this, it's consistently the same thing. Slips, trips, and falls on the same level, it still cause a lot of fatalities. Falls to a lower level are the most dramatic. Interestingly, I saw a stat earlier this week, and I'm not into this category yet, but for people 55 years and older, In fact, I'll be, not to be too personal, but I'll be in that category in about a week. But for people 55 and over, falls in the same level are a much higher category of fatalities than other levels. So, but my point is, falls to a lower level from collapsing structures or equipment, and falls through the same surface or an existing opening, like a skylight, like a shaft, that sort of thing, cause a lot of fatalities, unnecessary fatalities in our industry. Again, this is more stats. This goes back through an 11-year period, and you'll see a curve. It dips a little bit just because less people were working at that time. That's what I believe. But falls continue to be the number one cause of fatalities in construction, and have, to my knowledge, ever since OSHA was established back in 1970. So just in my region, I mentioned in my region, I'm based here in flyover country here in Kansas City. In my region, it's called Region 7. And within that region are the states of Missouri, Iowa, Kansas, and Nebraska. And the good folks at OSHA, the regional office here, I attend a trade show, which I speak at a lot of times, do training and education at that trade show. And they do a presentation. They're nice enough to do a presentation every year, and they give us stats and updates and that sort of thing. So, just in my region, in those four states, this was over a 6-year period from 2018 to 2024, struck by accidents, which encompass a lot, could be a vehicle, could be a dropped object, and a lot of other things, are the number one cause of fatalities. But falls, again, are right up there, and one or two, falls from elevation, caught in between, and then electrocutions were the fatalities in my region, in Region 7. That's the OSHA region in my area. Just in Kansas City, and this was again from the OSHA update back in March, early March, that they did a trade show, local construction trade show here in Kansas City. If you look at the hospitalizations, what was number one? Of course, falls from heights. There were 6 workers. And again, that was fiscal year 2024. This presentation was given in March. So you're talking about a 2-month period. Struck by 3, caught in was 1 worker. And again, electrocution or electrical shock was 1 worker as well. So my point of showing all these stats and going over this is the emphasis on falls and struck by and all that, and how dangerous it is, impactful to the construction business. Some more stats as far as slips, trips, and falls and falling objects. There are two stats here. From 2011 to 2019, a total of 805 construction workers were fatally injured by being struck by an object, and I believe one of those was, relatively infamous or famous accident in Jersey City, I believe it was, where a delivery driver was struck by a tape measure, and it killed him. I think that tape measure fell over 50 stories, and really, the only one of the good things that came out of that is people started looking at dropped objects prevention that came out of that. So more of an emphasis on that. But that's a tragic accident, and obviously there was 804 more of those like that. And then just in a 3-year period from 2018 to 2020, an average of 376 construction workers died due to slips, trips, and falls during those 3 years. In Germany, we're not the only ones that have construction accidents that lead to fatalities. Germany is a European country, very advanced in a lot of their techniques and safety. I believe they are, but they still have severe brain injuries due to slips, trips, and falls. Nearly 60% were caused by slips, trips, and falls, and only less than 20% were a result of falling objects. This is a couple of different photographs I took here in the Kansas City area. I can't mention where either one of them are, but I mean, one on the right is a very famous construction job site that just wrapped up about a year and a half ago. And again, my point is, there's just a lot of areas where prone to falls for falling objects. You can mitigate it as much as you can by organization, but it's just a nature of our business. And the one on the left is not really a construction site. It's a repair center, but you can look through there and just see all of the, not only slips, trips, and falls, but there's a variety of hazards in that area. And again, some of them can't be avoided. Most of the folks I've worked with try to do as much as they possibly can to avoid it, but there's some things that it's virtually impossible to avoid. Some risks just can't be mitigated, and therefore that's why you need personal protective equipment. So we'll talk about traumatic brain injuries. What is a traumatic brain injury? It's basically an injury that affects how the brain functions. There are three types. There's mild, moderate, severe. A concussion is the most common form of a mild traumatic brain injury, or TBI. It's a generally used term, but a concussion is, like I said, it's the most common form of it. And this is not just construction related, thank goodness. This is all related deaths, to traumatic brain injuries. But on average, there are 64,000 TBI related deaths here in the US. And that could be a variety of causes. Could be accidents, vehicular accidents, could be somebody falling off a ladder at home cleaning their gutters. It could be all kinds of things. But that's a lot. I think I read a couple weeks ago that there are over 20,000 emergency room visits per month here in the US due to slips, trips, and falls. And again, most of those don't happen at work, they happen at home. So, working on a construction site is risky, but so is working at home as well. On average, it's 176 per day, and that's an awful lot. And falls led to nearly half of the traumatic brain injury related hospitalizations. And I'll mention one thing about traumatic brain injuries. The results are easy to see. They call it the invisible, the invisible, disability, because it's you can't see the actual damage done to the brain, but you can see the results. They're clear as day. So more stats. How common are traumatic brain injuries construction? As you would expect, for a variety of reasons, they happen 2.5 more times likely at smaller companies than larger companies. There's a variety of reasons related to that. I think training, education, sometimes resources. When it comes to a larger company, they have more of those than a lot of smaller companies. And as you can imagine, that the type of workers that are most prone to a traumatic brain injury are folks that work at heights. Again, what have I mentioned? Slip, trips, and falls. I showed all the stats about falls in construction. Well, therefore, you would understand that structural iron workers or steel workers, and roofers have the highest fatal rate of traumatic brain injuries related to falls. And most of the falls come off of roofs, ladders, scaffolds. Over half of the work-related traumatic brain injuries come from those applications. And I'll mention one thing. I think I talked about chin straps before. Just in my market, again, I live in Kansas City. I know of at least 3 cases where where workers died from either falling off a scaffold or a ladder, because the head protection that they were using fell off their head as they fell. So it provided zero protection as their head made impact to the surface that they landed on. So construction falls and falling related accidents related to traumatic brain injuries. So falls obviously were 29%, in contact with objects or equipment is 18%. And again, construction recorded nearly half, or those 3 industries: construction, transportation, agriculture, which incorporates, forestry, fishing, and that sort of thing, nearly half of all traumatic brain injury fatalities. So some of the science of head injuries, and we'll talk about rotational motion. It's usually a combination of rotational energy or angular velocity and rotational forces or angular acceleration that can result from a oblique impact to the head, not a linear, an oblique. And we'll talk a little bit more about that as we go along. And because the brain can deform and shear, and which causes damage to the axons in the brain. And the axons are what transmit the information from the brain to your nerves, to your muscles, and that sort of thing. So that's what is why rotational motion can be very destructive to the human brain. And again, we'll go into it a little bit further with some graphics and other things. During most impacts, when your head related to your head, both linear and rotational motion occurs, which gives an increased risk of injury, because both can be traumatic, especially if you're not using the proper head protection, whether it's a linear impact or rotational. And again, like I just said, usually when your head hits a surface or something hits your head, both are going to occur. Again, we believe that concussions and TBIs are caused by rotational motion, which causes strain to the brain. And we'll talk about strain to the brain a little bit in a few slides, and how that impacts and how you can kind of relate that to the concussions or traumatic brain injuries. So again, I mentioned it previously. We believe that the injury statistics prove that when someone falls, due to a trip, slip, or from a higher surface, or they're struck by a falling object, the impact is most likely to be at an angle instead of directly on top of the head or even at the side of the head. So we have a science department again at MIPS, and we have over 50 engineers, and I'm not one of them, even though I went to engineering school. But we have over 50 engineers that do a lot of testing and studies related to slips, trips, and falls because our whole emphasis is on head protection safety. And so in one of our labs we have a we have a way to virtually show what happens to the head during different impacts, different falls. And obviously there's four scenarios there where it shows impacts related to different types of falls from elevated surface. Again, this person, or not the person, the animated person, is not using any fall protection, so they fall to the lower level and hit their head. And as you can see, it's a variety of different ways. The image on the bottom left here was from I'm sure that most of you related to fall protection and safety have seen it. It was a gentleman, a worker that fell in an environment, and he was luckily, he was connected. It wasn't connected correctly, in my opinion, but it did keep him from hitting the lower surface, but he did have a swing fall. And some of the other scenarios in our lab, in our test lab, show what happens when somebody falls from an elevated surface, how the body reacts and how the head reacts and how it hits that lower level. Again, in that scenario, the worker was obviously not using proper fall protection. But the next one, the one on the far right corner, that worker was. And although the body did not hit the lower level, the ground, it still hit the surface, the vertical surface, due to swing fall. And those of you again that are involved in fall protection understand, hopefully you understand the risk related to swing fall and using the proper anchor points, using the proper techniques when it comes to connectors and that sort of devices. Understand the importance of that. And my point of it is that, again, as you can see through the animation, the head still comes into contact with a vertical surface during a swing fall. That's why head protection is so critical. So let's talk a little bit about the history of hard hats. So you folks have probably seen this, especially the ones involved in head protection, the business. Hard hats have been around, head protection have been around for over 100 years. E.W. Bullard invented it, the hard-boiled hat. It was leather. They boiled it to resist dropped objects and that sort of thing and give head protection. It was a really good idea. It started with the U.S. Navy and shipyards and that sort of thing. So that's where it all got started, with leather. And then the same company put an inner suspension in, which was a great idea. That's still being used today, almost 100 years later, for impacts to the top of the head. It was a great idea to absorb that impact. And that's what happens in a ANSI Type 1 hard hat or helmet, is to absorb that force. Then we moved on to aluminum hard hats in the 1930s, mainly because the lighter weight and more durable. Found out, not long after that, there were better options when fiberglass became available in the 1940s. After World War II, it was used in a variety of applications, and then it applied to head protection. It was the best choice for high heat applications because, as you can imagine, aluminum transfers a lot of that heat, so people don't want that on their head. Then finally, the last 60 to 70 years, we've used plastic injection molded hard hats. And that's been around and been the standard for a very long time. And whether it's type 1 or type 2, a lot of them are injection molded plastic, which works fine. If it passes the ANSI or the EN test, it's a suitable application as well. So what's happened, like I said, here in the US in the last 8 or 9 years is we've moved towards helmets. And some of the attachments, have come a long way too with hard hats and helmets. There's been different types of face shields, better hearing protection, integrated eyewear that's been, incorporated into the helmets and hard hats, and then chin straps. And again, we believe here at MIPS, we require anybody that uses our system that they have a chin strap and they use the chin strap. It's important to not only have the chin strap on a head protection, but really the user needs to understand that they have to use the chin strap in order to keep the helmet or the head protection product on their head. So just the basics for those of you that don't know, the difference between ANSI Type 1 and Type 2. Again, I mentioned the suspension system that E.W. Bullard had invented And what that does is reduce the force of impact to the top of the head through that suspension system. It acts like a shock absorber. And the ANSI Type 2 can incorporate the suspension system with some sort of foam material or some sort of shock absorbing material. It doesn't have to be foam. It can be a 3D, structure that some folks use, but some sort of material that absorbs that protects against the top and lateral impacts. And there are three classes: general, electrical, and conductive, as far as ANSI. I asked my counterpart, Chris Tidy, who sits on the board over in the UK and Europe. He put together this slide. It's a pretty busy slide. I'm not going to go through it. If you want to see it, I'll send it to you. And what he basically helped me do is, showed the differences in the standards. People ask, when I do training or when I talk about rotational motion or talk about head protection in general, they want to know the differences between the two standards, the EN standard and the ANSI standard. And if you look on the slide, it's very busy for a reason. We didn't even cover all the type 2 as well, but different weights are used, different heights are used, even within EN, even ANSI, as far as penetration and shock absorption, and it's different. And I tell people, again, I mentioned that I've done a lot of hand protection and fall protection training as well. This is very similar to me. It is to the hand protection cut resistance standard. ANSI and EN a few years ago came together as far as agreeing on how the cut resistant testing is done for the most part. But again, their standards are different when it comes to how the cut is measured through the material. Again, you can argue about who's right, who's better, who's not. But as of right now, there's two different standards. There's ANSI and there's EN. And those of you that aren't familiar with EN, that's the governing body similar to ANSI over in Europe. So what makes a safety helmet? Typically, again, they're even though it's not required currently by ANSI, chin straps are usually incorporated into a safety helmet. Again, I'll mention it again. We here at MIPS require it to be used on your product that use a MIPS because it keeps the helmet on your head during impact, which is the most important time. Again, when it comes to training and education, the users need to be reinforced on why they have to have that chin strap. And I know there'll be a lot of pushback of all of the things related to new head protection products. It seems like chin strap, believe it or not, are the most pushback. At least it has been for me in my years of doing it. Generally, they have a sleeker profile. They look cool for the most part. I know when they first came out, I would get the comments that, hey, did you ride your bike to work, or did you come off a mountain, and those sort of comments. Again, still get them from time to time, but not as much because the industry has come out with some better designs and better looking products. And again, the accessories are a big deal when it comes to helmets. There are some really great companies that have incorporated some phenomenal accessories to make the worker safer and more productive. People talk about the cost of helmets related to hard hats, and I know that type 2 helmets in general are a lot more expensive. But so is a concussion, so is a head injury. OSHA has a estimator, and I got this information directly from their website. I don't know if most of you have seen it, but you can go on there and do a direct cost analysis on their website. It's free to use. And related to a concussion, it's according to OSHA, the average direct cost related to a concussion are over $54,000, almost $55,000. So you have let's say you have 100 workers. Let's say you have 10 workers. One concussion is going to cost you almost $55,000 on average. So, I mean, that pays for a lot of head protection products. So we're going to talk about rotational motion and brain injuries. Traditional safety helmets are designed and tested for linear impact. We test for rotational motion, which we believe causes the majority of the brain injuries, especially when it comes to impact. So what types of injuries dependent on that type of impact? Most linear impacts cause injuries such as fractures, which can crack the outer shell of the skull. You're fracturing that protective layer. It can also cause an epidural hematoma, which is bleeding on the surface of the brain. And it can cause a contusion, which is another name for a type of a bruise, in essence. So when it comes to angled or tangential impacts, they can cause more severe injuries like concussion. Again, a concussion is the most common form of a mild TBI. It's a general term for a brain injury, but it's related to traumatic brain injury. You can also have subdural hematoma, which is bleeding inside the brain, on the surface and inside the brain, and a diffuse axonal injury. And again, axons are the things that transmit the signals from the brain to the parts of the body. And those studies on the bottom right-hand corner is where all that information came from. So head injury metrics. How do you measure the head injuries? Well, there's a couple different ways to do it. As far as skull fractures are concerned, we use peak transitional acceleration. The head injury criteria, stress to the skull bone. That's what the Hicks formula is. It's basically measuring the stress to the skull bone. What we do for metrics for concussion is we use peak angular velocity, or PAV, and we use BRICS, the brain injury criteria. And that's what is a more common use for showing more traumatic brain injuries. You combine the probability of a concussion using both of those. So you use the peak translational, acceleration, as well as the peak angular velocity, or angular acceleration, which results in strain to the brain. What is strain in the brain? Well, a guy named Sven Kleiven, and I hope I didn't butcher his name too much, but he's out of Sweden and works for the Royal Institute of Technology in Sweden. He did a study back in 2007, and it's referenced here on the right-hand side, of 58 NFL head injuries of cases to compare predictors for mild traumatic brain injuries using a finite element computer model of the brain. And I'll get into that. I'll show an example of that. And that the FE computer models only exist at the Royal Institute of Technology in Sweden. And so if you don't have that, access to that, and again, I'll show you examples of what that shows, but if you don't have it available, you have to use the peak angular velocity or the BRICS criteria to measure the short duration of the brain impact. So this is what I was referencing, the FE model simulation from his study. So both of these, so pay attention to the one on the left, and I apologize, sometimes I show these, a lot of times I show it where I show one and then the other, but in this situation, I think it'd be best to show both at the same time. So the key points of this are two things. So the one on the left shows a direct linear impact at, perpendicular to the surface. In the graph on the right-hand side, it shows the fringe levels. That's measuring the strain in the brain. And you see the brain colored, it starts as a dark blue. As the strain levels get higher, the color inside the brain changes, therefore, and it gives you a value over here to the right. You look to see on a linear impact, one that's straightforward, perpendicular. You see very little strain level. It goes up to maybe to this area here, the light bluish green. The one on the right is at an angled impact, about a 45-degree impact. Again, this is using an FE model simulation that he used in the study. So look at the discoloration in that brain, again, in the brain simulation, and compare it to the strain levels on the right. And we'll get into that, why that's important. So again, you see the coloration different, it's dramatic. A 0 degree or a perpendicular impact, linear impact, versus an angled impact creates a lot more strain in the brain when you introduce an angled or the rotational motion into that. So what did that mean to him in his study? So the probability of a concussion is relative to strain level. And again, the strain level was measured based on the rotation of the brain on those FE model simulators. And so what he found out is strain level in the brain, the gray matter, is relative to the probability of concussion. So if you get up to a 0.26 strain level, that equals a 50% probability of concussion. It equals right there. So if you can reduce the rotational motion due to that angled impact, and what you can do is dramatically reduce the probability of concussion because you're lowering the strain level in the brain. So that's what the whole point of this graph is finding a way to lower that strain level in the brain, in the gray matter of the brain, and therefore you lower the probability of concussion. So what does MIPS do? We have a low friction layer system that it's designed to reduce that rotational force transferred to the head by redirecting the forces. It's a 10 to 15 millimeter movement. So it's not a lot, 10 to 15 millimeters. But the main thing is it's in a very short period of time, because the most critical of 5 to 10 milliseconds. So if you think of a blink of an eye is 100 milliseconds. So it's less than 1/10 of that is when that critical impact happens, that 5 to 10 milliseconds. And people will often tell me when I do training or consulting or show them the products and how it works, they'll say, they'll grab their hard hat or their helmet and they'll say, well, mine moves. Well, it moves already because of the suspension. Well, that's not necessarily true when you subject it to a load. And some of the point loads can be over a ton of force, over 2,200 pounds of force on your head. Therefore, we believe that you need that low friction layer in order to allow that helmet to move, and not your head, and therefore not your brain, and increase that strain level. I keep mentioning fall protection because, again, it's so critical to the construction industry. If you guys have ever seen myself done training, or some of my counterparts, the folks that I learned from around the country that I did, we would drop a mass of over 200 pounds, and it would generate thousands of pounds of force in a 4 foot, 5 foot, 6 foot fall. So it's easy to see when you fall on your head, you can generate a lot of force. And again, it's that force that keeps that helmet from moving, unless you have a low friction layer or some sort of a rotational mitigation system in that as well. So I'm a very visual person, and most people are. So they want to see what happens in a linear impact to the brain. So the brain basically is more like a gel. It's has the consistency of gel. It does not compress. That's why it's more resistant to linear motion instead of rotational. It's more like water. And we often use a snow globe to demonstrate that point. And you'll see when she slides the snow globe across, it's a straight impact, it's a linear impact, and you notice that the snow doesn't move. But when she rotates it, when she spins it, you'll notice that the snow moves quite a bit. And I'll play it. Again, the linear impact, no movement of the materials inside the snow globe, but the minute rotation or spin is involved, that introduces the strain and the movement inside the brain. So in summary, because I want to wrap this up and allow time for questions, because I'm sure there are some that have come out. In summary, head protection keeps people safe at work. The employers need to provide their employees with better head protection and do training and education. Make sure they do a risk assessment to determine which product is best. Injuries come at a cost. I mentioned they're an OSHA calculator, the cost calculator, almost $55,000 due to one concussion. That's the direct cost for that concussion. But there's a variety of other costs that are related to it too, when it comes to financial implication to the victim, and what it does to their life and their coworkers' lives as well, and a cost to the organization. Different helmets are designed for different types of situation. Make sure you educate yourself, choose wisely. And most helmets are typically not designed to address angle impacts, but there are definitely those that are in those situations. And most importantly, make sure that your employees know how to wear their head protection correctly. And I know this is an election year, and I know that hopefully that doesn't offend people, but I just thought it was funny that our current president wasn't using his head protection properly, and I was trying to make my point. So if that bothers anybody, I apologize. I just thought it was funny, regardless who you vote for. And again, that's the presentation. We'll get on to some questions. Barry, if you've got some. My name, again, is Joe Brandel. That's my email address. That's my mobile number. And again, if you want to talk about anything head protection, or if you want to talk about my training with the Chiefs, I'll be glad to do that.
Well, Joe, thank you so much for sharing your knowledge with us today. Great presentation. Before we start the Q&A, I want to let everyone know about the evaluation survey we're asking you to complete. The survey will open up in a different screen after this webinar, and your input is important to us because it does help us to improve our future webcasts. We're going to get to as many questions as we can, folks. If we don't get to your question, we will forward all of those along to Joe and his colleagues at MIPS for them to respond to. Joe, I wanted to start with you. I think it's interesting to point out, to clarify a little bit, Kathleen from our audience asked about OSHA's time frame for making this mandatory. And I wanted to just clarify that safety and health bulletin you talked about and we wrote about in our magazine. That's a change OSHA made with their workforce, and they also only recommended it for certain industries, construction included. Can you speak a little bit to that safety and health bulletin and the fact that this is not mandatory? It's something that OSHA is recommending.
Yeah, it's a good question, and thanks for asking that. It's important to recognize that, yeah, they are not requiring it yet. OSHA moves very slowly, uh, you know, as an organization for a variety of reasons. But I don't see that requirement happening anytime soon. Probably not even in my career. Hell, it may not even happen in my life, depending on how long I live. But I don't think you'll see that as a requirement anytime soon. I did reference they do it occasionally. I did reference the body belt to the harness situation, but again, body belts were used for decades before they were required in 1998 to no longer be used for fall arrest applications. So to answer your question, I don't see it happening anytime soon as a requirement.
Yeah,
That's
Joe, and I think you're well aware that OSHA standards take between 10 and 20 years in most cases.
Yep.
So this is something that we may not see, like you said, in our lifetimes. I did want to mention, Joe, you talked about um, from our poll, 30% of workplaces using helmets, and you've seen it obviously in construction. OSHA did recommend also oil and gas and other industries. Can you talk about any industries where you've seen growth in the use of safety helmets? Or any specific construction settings where safety helmets have really become more popular?
And going around the country and talking to safety managers and just seeing them in action, I think working at heights, again, is as far as construction, I think that's where we're seeing the most growth of that. As far as and that's really any industry across the board. If you think the tower, the wind, there's been a lot of wind turbines because of clean energy going up. Folks working at heights in oil and gas. I think that's where you're seeing it, not just from the standpoint because there's always going to be risk when you're working at a height. The fall protection apparatus, even a safety net, or even something like that, you still have the potential of hitting your head. Even a safety net has some sort of a structure keeping it in place. Well, your head can hit that as well. So that's where I see it most happening and most frequently. Anywhere there's a potential for slips, trips, and falls. And again,
Certainly.
I want to reference this again. I mentioned at least twice. I'm not here to say type 1 hard hats are not safe. They're safe in certain applications and they're certainly adequate. But I believe, a type 2 type helmet, ANSI type 2, with the especially with a MIP system, is offers you the best protection on the market.
Great. And Joe, I did want to ask about, you are no stranger in Kansas City to summer heat. The folks, our team here in Chicago is going to see 100-degree heat indexes this weekend. I wanted to ask you about how can employers make sure that employees are wearing helmets on job sites, even when we have such high heat conditions like we're having this weekend?
No, it's a good question. And I get that every summer. And the workers are always going to push back, and I understand why. Generally helmets, especially Type 2 helmets, are going to be hotter. They're just due to the standards, the way it's tested. You can't put enough vents on there to ventilate the heat out of your head. So they're generally going to be hotter. Some manufacturers have gotten some good technology with reducing that heat, but a lot of times it's not enough. So to answer your question, I think the best way to do it is continue to educate your workers, tell them why they have to have that helmet. You need to educate them on the risk, why they're required, how serious a head injury is and how it can impact your life and your organization, your family. If you have a traumatic brain injury, it could kill you, but it could damage you for the rest of your life. So, it's important to wear that proper head protection and to wear it correctly.
We had a question come in, Joe, regarding bump caps. Someone wants to know that their organization uses bump caps. Can you talk a little bit about the differences between safety helmets and bump caps, and the difference between those two for our audience?
I mean, basically, bump caps offer the very minimal protection. Just by the name, it's to protect you from bumping your head on an object. So there's different levels of protection. I would say that's the basic the most basic protection you can wear. And again, bump caps are adequate in certain situations. You see them a lot used in different industrial environments, manufacturing. I see it a lot. In my area, we build a lot of aircraft. So I see it in that. I see it in food processing. And again, where the risk of injuries, whether you're bumping your head, a contusion, that sort of thing, I think it's fine. I think though, you need to do a risk assessment, make sure that it's adequate because if there's any dropped objects, any risk of a slip, trip, and fall, you probably need to upgrade your head protection.
Great. Jill Leslie from our audience has a question about brimmed Type 2 helmets. And Leslie said, I've seen rods fall down and glance off them due to the brim. Any comments about a brimmed Type 2 helmet?
Um, I mean, they're not required. I mean, some companies have, very micro brims. The manufacturers I've sold over the years had a variety of widths and lengths. I've never seen that application. A lot of times, when the brim comes into play, a lot of the folks, especially in traditional industries, want that wider brim mainly for, dropped object protection. But I think for the most part, it's to protect you from the sun and the elements. So the brim, the helmets are tested in a variety of brim types, but you may want to go back and determine whether that brim is the right option, whether it's a full brim or the extended brim on the front. Hopefully that answered the question.
Great. Thank you for that. Um, Next question for you, Joe, is what do construction managers and workers often overlook or maybe need additional training on when it comes to safety in construction? And how can these items be addressed?
Definitely through training and education. A lot of times, again, I mentioned chin strap. I can't emphasize that enough. I over the years of selling the products, we get a lot of pushback on that. I don't want to wear it; it's not comfortable, and I get that. I mean, some chin straps aren't, especially the way they're designed, and kind of you get what you pay for. But it's important again to educate the users on different technology. Well, number one, the risk, why they're wearing the helmet or the hard hat, and then really what types of mitigation systems are out there for rotational motion, for linear impacts and that sort of thing. I believe that the users, the workers need to be educated, basically constantly on different types of PPE, especially in head protection, because it's been an emphasis again the last decade for sure.
And Joe, just to follow up on that, I know you mentioned chin straps earlier, and OSHA did talk about the benefits of chin straps. Can you discuss a little bit what you feel the most beneficial parts of a chin strap would be?
I mean, I mentioned at least 2 or 3 times, we require it, MIPS does when
Hmm.
we put our helmet. So, I mean, the most important thing is keeping that helmet on your head or the head protection product on your head during a fall or during a falling object. I mean, that's the most important part. Again, I think I mentioned it that there were several accidents here in my region, in my area, where someone fell off a ladder, someone fell off scaffolding, someone fell off a wall, and they hit their head because their head protection product fell off. So, I mean, the number one thing that chin strap does is keeps that head protection product on your head.
Great. Um, Joe, someone asked about resources and where can construction managers get more information or some online resources to understand that rotational motion piece of this?
We've got a really good website. It's mipsprotection.com. We've been doing this for 25 years, over 25 years. It's all we do. Is head protection products. Every employee is pretty much dedicated to it. We were started by a neurosurgeon, so there's a lot of science behind it. You know, um, and that sort of thing, and that's a good resource. And my competitors do as well. There's a lot of ANSY's another good resource for, especially linear protection. They haven't really addressed rotational motion yet, but it's a good resource. Those of you that are part of ISEA, Cam Mackey and his group does a really good job, as far as education and that sort of thing. If you can get on their website, have access to it, or through one of their members, there's some really good resources in that as well.
Great. We appreciate that, Joe. Looks like we have time for one more question today, Joe. And I want to go back with you to one of your first slides. And I'm sure we have some football fans with us today who would appreciate just a little brief story about how you came about training Peyton Manning and Patrick Mahomes. Can you tell us a brief story about that?
I'll tell it real quick because I know it's going to end. So basically, what happened is the Chiefs, one of their safety directors, I'd worked with in the construction business. He came on board with the Chiefs, and they had a film crew came out. And Peyton Manning has a show called Peyton's Places,
Hmm.
and it's on Netflix, I believe. I don't watch a lot of TV, but it was about the Super Bowl and how it was named. Lamar Hunt came up with that Super Bowl terminology by looking at the Super Bowl. So they wanted to throw balls off the top of the Arrowhead Stadium, and there's a lot of slips, trips, and falls. And they wanted to do it off of one of the the light areas where the light fixtures are. And myself and one of my counterparts talked them out of that because it was risky, and they ended up doing it off of the roof, which there was a 4 foot tall parapet wall. You could see that in the photograph,
Hmm.
and that's what they did. But there's still trip hazards, and you've got a guy that signed a $500 million contract. You kind of want to keep that asset protected, as well as the Hall of Famer Peyton Manning as well. I mean, they're both important people. But here in Kansas City, we wanted one into the Super Bowl. So
Absolutely. Well, Joe, thank you for that sharing that story. It's great to hear about. Folks, unfortunately, we've run out of time today. We thank you all for attending this presentation, and we'd appreciate you taking a little bit of time to share your feedback via our survey. A big thank you goes out today to our fantastic presenter, Joe Brandel, and of course, everyone from the team at our sponsor, MIPS. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.